Hello everyone, my name is Muhammad Haffiz bin Muhammad Fariza and my metric number is 162679. My partner's name is Nur Zawanis Husna binti Zakaria. We are from group T3D. Today I will show you how to do a projectile motion experiment and I will answering some of the following questions.
Okay, before we go through the procedures, I tell you the objective that we're going to observe in this experiment. So first, we need to find a projectile range as a function of inclination angle. Second, we need to find a maximum height as a function of a projection angle. And the last one is we want to determine the value of gravitational acceleration. Let's go to the procedure. Now, we will use the ballistic unit and ballistic pendulum for launching the steel ball. We can adjust the angle by loosening and tightening the screw. First, we need to set up the initial angle, which is 25, and each will increase by 10 degrees until we reach 65 degrees. Next, this is the recording paper to mark the range of the steel ball. After we launching the steel ball, it will touch the recording paper. In this time, we will mark it using pen, and then the steel ball will bouncing and get into the box. Okay, next, this is the meter rule to observe the maximum height of the steel ball by using our eye. In this case, we record the video when launching the steel ball because it flies with a fast acceleration. So we pause and measure the maximum height. Okay, now let's move on to the Q&A session. So the first question is, what do you think is the best angle of projection to start with the experiment with? Okay, for my personally, by putting a 45 degree is a best angle of a projectile motion. It is because the steel ball able to stay for a long term duration in the air, and this will lead a maximum projectile range on the x-axis. Alright, so for the second question is, suggest a way to accurately measure the height of projection the steel ball in this experiment. So, I totally believe that a way to accurately measure the height of projection of the steel ball to be more accurate is by using the formula maximum height of projection h as a function of the angle of projection theta. So the formula is h equal v naught theta over 2g times sine square theta. This is will solve this problem. So if we use the meter rule and we observe with our eye, we cannot read it properly because the steel the steel ball fly with a high acceleration. So maybe we got an error to find maximum height of projection of the steel ball. So in conclusion, by using this formula, it will be more accurate. Now let's move on to the question 3. Suggest a way to determine the time taken for the projectile in this experiment to reach the maximum height. So since the explanation is so long and we need the image of how do we describe it, so let's move to the next slide. Okay, this is the solution. So I believe that by using a formula Vfy equal to Viy plus At will solve this problem. So what is Vfy Viy? So Vfy represent the final velocity at y-axis and Vii represent initial velocity at y-axis. And the A here we will replace with a gravitational force which is G equal to 9.81 meter per second square in terms of negative. So I give you an example. An example, as you can see the right one. So you imagine there are a steel ball that we launch with the initial velocity 3.00 meter per second. For sure that the velocity will become decreased as it reaches the maximum height. We can conclude that the final velocity Vfy is 0 meter per second. Alright, so by using Vfy equal to Viy plus gt, so you know lah, A, we replace it to the G. So we still using the Vfy equal to Viy plus at, but the A, we replace it to the G. Okay, so let's solve the formula. Okay, so the Vfy we know the 0. Okay, so Viy also we know the 3. So A also we know G is 9.81 meter per second square in the terms of negative. So 0 equal 3 plus negative 9.81 times t. So the times taken, we just use our calculator and we got 0.31 second. Okay, so okay, that's the answer. We can determine the time taken when it reach the maximum height by using this formula. Alright. The question number 4. From the theoretical physics point of view, will the type of material of the ball affect the range and height of projection? Why and why not? So my answer is no. It is because that any kind of materials like alloy, wooden, steel, or any type of materials for this ball does not affect to the result in range of projection and also the maximum height of projection. Okay, so the last question is, if your answer the question 3D was no, explain why in the real experiments performed there are still significant discrepancies in the range and height of projection obtained using steel and wooden ball. So the answer is the discrepancies in the range and height of projection obtained using steel and wooden ball. In real experiments, it could be due to factors such as differences in surface roughness, which can affect air resistance and imperfection in the balls. Okay, so that's all for the projectile motion. I hope you enjoy watching this video. So that's all for me. Thank you for watching from the start until the last. So thank you and see you again.